All right, still working under sample problem 3-5. Let's do practice problem number 1. What is the mass in grams? So our answer needs to be in grams of 7.5 times 10 to the 15th atoms of nickel. So we're going from atoms to grams, right? From atoms to grams. We're gonna have to use 2 conversion factors to make that happen. Well, let me point this out before we get started. That 7.5, that is 2 significant figures. So my answer needs to be reported with 2 significant figures. Okay, so I can tell that right now. All right, so let's set up our conversion. Now we're going to start with atoms, and I'm going to end up using a lot of my board here. Atoms of nickel. Well, if I start with atoms of nickel, that means atoms of nickel will be the denominator here. The only thing that I can convert into from atoms is moles. And I know that's the only thing I can convert into because in terms of my statements of equality, I have 1 mole is equal to 6.022 times 10 to the 23rd atoms. There's no other statement of equality that involves or uses atoms and anything but moles, right? This is our only statement of equality that we have. And so that means that I can only convert atoms into moles. That's it. Okay? So this is going to be our first conversion factor. Our second conversion factor, you can see that atoms will cancel here. Atoms will successfully cancel, and the only unit I'll have left is moles. And so I'm going to set up my second conversion factor, assuming that I'm starting with the unit moles, because in this case I am. So I'll put moles of nickel down here, leaving grams of nickel up in the numerator, so that when I actually calculate this out, moles of nickel will disappear. So what's my statement of equality for the molar mass of nickel? Well, 1 mole of nickel is, what's that? 58.69 grams. And so now I have the 2 statements of equality I need to set up my 2 conversion factors. That's going to allow me to convert from atoms all the way into, notice that grams is the only unit I have left. So, again, first conversion factor, what numbers do I use? What do I put in front of mole? Whatever's in front of mole here. What do I put in front of atoms here? Whatever is in front of atoms here. Second conversion factor, what do I put in front of grams? Whatever's in front of grams here. What do I put in front of moles? Whatever is in front of moles here. And now I am set up. Oh, I didn't use my initial given. Sorry. So 7.5 times 10 to the 15th power. Okay. Again, I'm not going to do anything with the powers of 10 right now. I'm going to do that at the end. So I'm only going to put the front portions of numbers into the calculator. So 7.5 times 1 times 58.69 divided by 6.022 divided by 1. All right, so the calculator, let's see if Dell's giving me a lot of extra digits that I shouldn't use because my answer should have 2 significant figures when I go to report it. So the calculator is telling me 73.0, let's see, 2 significant, so let's stick with 73. All right, so I have a times 10 to the 15th divided by a times 10 to the 23rd. So that is to say 15 subtract 23 That's going to be -8. So that's 73 times 10 to the -8 grams of nickel. But we're not done yet because that is not in proper scientific notation. In order to be in proper scientific notation, I'd have to take the decimal and move it here. So I'd move it one place. I'd move it one spot. Okay. So I'm going to end up with 7.3 times 10 to the something power grams of nickel. The question is, because I moved the decimal in one place, do I make this -8 one larger or one smaller? Well, again, this is the way I like to reason this out instead of just relying on memorization of rules. This number 73. 73. In order to make it in proper scientific notation, I had to make that number look smaller. Right? 73 down to 7.3. Well, remember, I'm not allowed to change the value of this information. All I can do is change the way I represent it. So if I change the way I represent this front part of the number, the front part of the scientific notation, by making it smaller, that means I need to make the exponent larger to balance that change in representation. And so it means I'm going to make this number one larger, which this is a negative number. So -7 is actually larger than -8. So my final answer is 7.3 times 10 to the 7th grams of nickel.